We have now in front of us a mechanical system that we would like to generate a bond graph over the system here, and let's just apply the same procedure as I have mentioned in the past. The first thing we're going to do is to use the one junctions to for the each angular velocity in this case. Then I'm going to put the one junction here for omega 1, and this of course it will be the same as the one in here, but obviously in here that is not the case, because we'll have to put the one junction for omega 2, and because we have this compliance element, this would be omega 3. Okay, and in here we can say that this is our one junction, which is omega equals to 0 for reference point. Okay, so what I would like to do is, in here we have we apply the principle that we put the elements that see those velocities. So this would be with j sub 1. This torque T is a source of effort, which we can add in here, source of effort with value the T torque. Then over here we have this I element with value j sub 2. This one that is a reference point, I'm going to call it the source of flow with omega equals to 0, with flow equals 0. And then we have in here the elements in between this. It's very obvious that between this and this we have a transformation, so I am going to draw it like this and say TF, and then go like this. We transformed omega 1 into omega 2, and at this point we need to worry about the relative velocities, and in this particular case I am going to say that okay, this is a 0 junction over here, so we will have in between we have a relative velocity that says is omega 2 minus omega 3, and attached to this velocity we have this C element with value 1 over k rotation, yeah? And then we also have this other one. Same way, we will say this is a 0, and then in between this is omega 3 minus omega, which is 0, right? This thing is 0, and then this is going to be the R element with value R like this. Value, no, B sub torsion, I think I called it. Okay, this model you can put it into the CAMG software, and the CAMG software is going to assign the causal marks and is going to assign the bond numbers. All you gotta do is to assign the direction in which they go. However, I think for practice, although CAMG will do these assignments for you, let's just practice this and see how it works. First we assign it to the sources, then we assign it to the i's in integral form. That sets the flow onto this one, the other one has to be like this. And the moment it did this, this other one has to be like this too. And sets the flow, that makes this one like this. This C you put it in okay, hold on for a second. We are not done with the eyes yet, so let's do the other one. The other eye like this, mix these two like that, yeah. And you see in here you have these two flows like this. The zero would need one effort like this, and that makes it also like this, yeah. And in here you have that the source of flow is like this, right? That makes this like that, and the moment we do that, this one becomes like this and like this, and everything completes correctly. Now we can talk about simplifying the bone graft model, but it's a step that is really, in my opinion, for computational purposes, not significant enough. We could leave it like that, and if you understand the model like this, the best. But if you like, we can do a little simplification on the areas where you know that in here this is really one like that, and this one is one like this, see? And this also is one like that. So we could come back and redraw the graph. If not, like I said, leave it there. Don't worry about it. But with the simplifications, again, with this, with these comments that I'm making, that this step is not really necessary, I still will. I'm gonna draw it so that you can see it in a little more clean way, perhaps you may say. And then you have this one over here like this, and then you have sorry, this could be confusing here. Let's just draw it correctly. Is this over here? So like that, and then we have the eye element over here like this, and then we would have the, with simplifying both of them, you will have the let's just do it right, the R element like that, and the SF has been suppressed because it's 0, right? Now this would be the simplified bone graft model. We could simplify this one. Let me see, here we have a, on the 0 we have, what did we have in there? We had a C element in here. Yeah. So if you want to complete this, you will go like this, and then mix this to be like this. That is like that. And then this other one also is like this, and then this C like this in the end, and everything is simplified and complete. But if you like, you can do this. Right? So these are the this is a mechanical system, a rotational mechanical system. Perhaps I think it would be a good idea to do another more complex mechanical system that has a more significant effects, and let's do that next.